Hi everyone, my name is Makumba Gerard of EduMath. In this video, we are going to look at error propagation in division. But hey, before we continue, if you are new here at EduMath, tap on the subscribe button, hit the notification bell such that you can be notified of the new videos that we make every day. So let us get started and see you there. Error propagation in division, and we are going to start with a guiding question. Show that the maximum error in A divided by B is this expression here, where EA and EB are errors in A and B respectively. So let us get started. They need us to find the maximum error in A over B. So as usual, we say let capital Z be equal to A all over B. The quotient here is going to have errors. So the quotient is Z, and is be an error in Z. Now since each of these variable has errors, so we shall have Z plus the error in Z, giving us capital A plus the error in the A divided by, we got B plus the error in B, right? So the next thing, because we are interested in the errors, we are going to take away the Z to the right hand. So you have error in Z being equal to capital A plus error in the A divided by B plus error in B minus Z. But what is Z? Z is A over B. So I'm going to substitute it there. So shall have error in Z being equal to A plus error in A divided by B plus the error in B minus Z, which is A all over B. Can you get the LCM there? The LCM, so our LCM is B into bracket B plus error of B. So LCM divided by this, you will have B multiplying A plus the error in A minus this LCM divided by B, we shall have to remain with A into bracket B plus error in B. Then we are going to open the brackets in the numerator. So shall have here AB, okay, plus B error A minus AB minus A error B. Everything divided by, we have B into bracket B plus error. So A, B, they cancel out there. So we remain with, we have B error A minus capital A error B divided by B into bracket B plus error B. So this here is error Z, alright? But what are we supposed to show? Let us see what we are supposed to show here. We are supposed to show this. That means we have to continue. Yes, we have to continue. Let's expand in the denominator. We shall have B error A minus capital A error B divided by B squared plus capital B error B. So next I'm going to pull out B squared from the denominator. So I will have B error A minus capital A error B all over B squared out. I will remain with 1 plus error B divided by B. Okay, this is AZ. Now assumption here, since AB is very small, so getting a smaller thing divided by a big thing, we shall have to approximate this term to 0. So there we shall now have error in Z, giving us B error in A minus capital A, error in B divided by now B squared. This part here has been approximated to 0 because of this reason. Small value divided by a bigger value, we approximate this to a 0. So if we happen to distribute the B squared, we shall have error B error A divided by B squared minus capital A error B divided by B squared. Okay, so right after there, this can reduce and we have error A all over B minus A all over B squared. Of course, here error B. Okay, next I'm going to take the absolute error on both sides. We shall have the absolute of Z is equal to the absolute this side, EA divided by B minus capital A error B divided by B squared. So we bring in the triangular law of inequalities. We shall have error in Z less or equal to error in A divided by B plus negative A error in B divided by B squared, right? Error Z less or equal to this magnitude signs absorb the negative. So we shall have error A divided by B plus we have A error B divided by B squared. So from here we get the maximum, of course, absolute on both sides here. So from here we now take the maximum error is the max is now equal to, since this is less or equal to, so the equal to is what makes up the maximum error. So you have error in A all over B plus you have A error in B divided by B squared. So the next thing here is I'm going to pull out A over B to get this here. Okay, so I'm going to pull out A over B. So A over B out, A all over B, this into brackets shall have here error A divided by capital A plus A over B is out, so we remain with magnitude of error B divided by B. So this is easy max. Okay, then right after here we can be able to get the relative error, which is equal to the absolute error divided by the exact value. So let us substitute in here. Our absolute error is right here. So when you put in relative error is now going to be equal to, we have A all over B into bracket, we have magnitude error A divided by A plus magnitude error B divided by B, everything divided by the exact value, which is A all over B. So this and that will vanish and we shall have the relative error being error in A all over capital A and the magnitude plus the error in B divided by B. So this here is the relative. So we can as well go ahead and get the percentage error. This here is equal to the relative error times 100. So this becomes our relative error is right here. Error in A all over A plus error in B all over B. Then times 100, and this gives us the percentage error. Right after that, we can now have an example. Given that A is equal to 3.3366 and B is equal to 0.559. State the maximum possible error in A and B. In other words, they need us to find the tolerance error in both values. Hence, find the error in the quotient, we are just going to use the formula that we have just derived about the errors in the quotient A divided by B. Then after getting the error, of course, it becomes simple to get the limits. Let's get started. So error in A, this is equal to absolute error in A is equal to a half times 10 power negative number of decimal places. This here has 4 decimal places. This here has 3 decimal places. So this is power negative 4, and our error, maximum possible error in A, is 0.00005. Error in B is equal to half times 10 power negative, this has 3 decimal places, or when you simplify this in terms of decimals, you have 0.0005. So this is the maximum possible error in B. But they want us to find the absolute error in A over B. Now, since this is maximum, we are also looking for a maximum possible error that is in the quotient. So we have error in A over B max. This is equal to A all over B into bracket. We saw this is the magnitude of error in A divided by A plus the magnitude of error in B divided by B. Okay, this is what we have just proved. Now, because we are interested in this error here, let's substitute. We have A, which is right here. We have B. We have error in A. We have error in B. So we can now substitute freely. So we are substituting there the absolute error in A over B max. This is equal to A, which is that 3.3366 divided by B, which is 0.559 into brackets, this bracket here. The error, the magnitude, we have error in A, which is 0.00005 divided by value A, which is 3.3366, and the magnitude plus magnitude error B. Error B is 0.0005 divided by B, which is 0.559, and the magnitude, and we close the bracket. So when you pick the calculator and you press, you will get 0.00543. Let me write these 3 significant figures. So let me check on our part A. So we are done getting the absolute error in the quotient A over B. Next, we need to find the limits within which A over B lies. Okay? So we know that limits of arteries, this is equal to, we have here the minimum value, comma, the maximum value. So here let's get first of all the exact value. Exact value is A all over B. A is 3.3366 divided by B, which is 0.559. So this gives us 5.968873. This here is our exact value. I've rounded it off to those number of decimal places. Now this exact value is going to be minimized and maximized in order to get the minimum value here and the maximum value there. So let's start by getting the minimum value. Minimum value is got by getting the exact value, which is 5.968873 minus the absolute error, which is 0.00543. So there we shall have to get 5.963443. So this here is our minimum value. Let us get the maximum value. Maximum value is equal to the exact value plus the maximum error. We have 5.968873 plus the maximum error, which is 0.00543. So when you add this, we shall be getting 5.974303, and this here is our maximum value. So therefore, the limits of accuracy is equal to, we are going to start with the minimum value 5 points, but remember also the degree of correction given to us, they needed it to 3 decimal places. So we are going to write the minimum value to 3 decimal places, maximum value also to 3 decimal places. So these to 3 decimal places, we shall have 5.963, comma, these to 3 decimal places 5.974, and this here is our limits for accuracy. Now someone else can go ahead and find the percentage error in this. Alright, let's do that after we have gone through this. But at the moment, I have one question that I want to leave with you at the end of the video, such that we can concretize the knowledge that we have achieved here. So our tryout question is right here. Let's go through it. And if you're new here at EduMath, feel free to subscribe, hit the notification bell, such that you can be notified whenever we upload our videos every day. So from us, EduMath, we wish you the best and God bless you.